Greetings everyone. Today we want to look at the determinant of a 3 by 3 matrix. But before we look at the determinant of a 3 by 3 matrix, we shall first of all try to recall a few concepts that we looked at in the previous lecture. So in the previous lecture, we looked at what we call the determinant of a 2 by 2 matrix. And we said that when we are given a 2 by 2 matrix, we shall be calling this diagonal here as the major diagonal, and we shall be calling this diagonal here with elements B and C as the minor diagonal. So basically we said to get the determinant of A, which is a 2 by 2 matrix having entries A, B, C, and D, then we simply multiply the elements in the major diagonal, that is A times D, this A multiplied by this, and we subtract the entries in the minor diagonal, which is B times C. And we said if A, B, C, and D are defined, then you can easily multiply and get the value of the determinant. So what will be our interest today? Our interest today is to look at what we call the determinant of a 3 by 3 matrix. So to look at the determinant of a 3 by 3 matrix, we shall still need to use the knowledge of the determinant of a 2 by 2 matrix. And I'm very sure that you already know how to find the determinant of a 2 by 2 matrix. So let us come to what we call the determinant of a 3 by 3 matrix. And for this case, we shall consider our matrix. We shall consider our matrix, which is having entries A1, B1, C1, A2, B2, C2, A3, B3, and C3. So when we want to find the determinant of this matrix, we shall take in consideration the first row. So let us take in consideration this first row. So looking at the first row, what are the elements in the first row? We have A1, B1, and C1. Now, what we shall do in order to find the determinant of the 3 by 3 matrix, we shall be using these elements A1, B1, and C1. Now, we shall say that to obtain the determinant, we shall first of all get this entry, that is A1. We shall get A1. We multiply it together with. Now, A1, where does A1 lie? A1 lies in the first row, first column. So what you will do is delete the first row and first column. When you delete the first row, first column, what are the elements that remain? We remain with B2, B3, C2, and C3. So you will simply get the first element, which is A1, multiply it with the determinant of the entries that remain when you have eliminated the row and the column where this A1 lies. So when we do eliminate the row and the column where A1 lies, we shall remain with B2, C2, B3, and C3. That is what we remain with. So we are now getting the determinant of this matrix A. You begin with A1, multiply it with the determinant of the remaining entries when you have eliminated the row and column where A1 lies. This value here lies in the first row, first column. So eliminate the first row, first column, then get the determinant of the remaining entries, which is B2, B3, C2, C3. Then after that, we are still considering, remember, this first row here. Taking the elements, these ones here, the elements, we consider the elements in this row. That is A1, B1, and C1. Then I1 is done. We shall subtract Now we are going for next entry, which is B1. So what we shall do is we still look at where B1 lies. Where does B1 lie? B1 lies in this row, the first row, and the second column. So what you do still, B1 lies in the first row. This B1 lies in the first row, second column. So to get the determinant that will correspond to B1, you eliminate the row and the column where B1 lies. So B1 lies in the first row, second column. When we do eliminate these, what do we remain with? We shall remain with A2. So get the determinant of the remaining entries. A2, C2, A3, C3. So get that determinant, then multiply it together with B1. Then again add there. Next we have C1. So we shall have C1 times, again let us do the same. Where does C1 lie? So we need to know where does C1 lie. So where does C1 lie? This C1 here lies in the first row, third column. So to get the determinant that we will multiply with C1, look at where C1 lies. C1 lies in the first row, third column. Eliminate or delete the first row, third column. When you do that, what are the entries that remain? We remain with A2, B2, A3, B3. So you will multiply C1 with the determinant of the entries that remain after you have deleted where C1 lies. Where does C1 lie? C1 lies in the first row, third column. Eliminate the first row, third column, and get the determinant of the remaining entries, which is A2, B2, A3, B3. So when you do that, then when you get A1 times this minus B1 times this plus C1 times this, what you get is the determinant of this matrix here. So this one here, what we have done will give us the determinant of the matrix, which is a 3 by 3. At this moment, I believe you know how to get the determinant of a 2 by 2 matrix, because we looked at that in the last lecture. So we are saying that the determinant of this is same as A1 times this, which is same as what we have done here, then minus B1 times this, which is same as what we have done here, then plus C1 times this, which is same as what we have done here. So when you get A1 times the determinant of this, minus B1 times the determinant of this, plus C1 times the determinant of this, what you get is the determinant of this matrix A. So we know the determinant of this is same as getting B2 times C3 minus B3 times C2. So that is what we have here. So after you have done this, you will simply say A1 times B2 C3. You are multiplying the elements in the major diagonal minus the elements in the minor diagonal. Then minus, this is the B1. Then you multiply by A2, the determinant here is A2 times C3 minus A3 times C2, which is this one. Then the determinant here is A2 times B3, A2 times B3 minus, in the minor diagonal, A3 times B2, which is this expression. So clearly, after you have done this, then what you obtain is what we call the determinant of a 3 by 3 matrix. So what are the major things we need to take into consideration? One, when we are considering, we consider plus, minus, plus. So that's why A1 will be a positive value here, but B1 here will be a negative value. So don't forget putting this minus there. This minus is very important. So when we are considering in this row, we consider plus, minus, plus, minus plus if they are continuing. So take in consideration of this minus. So the B1 is started with this minus, so that's why we subtract here. But we shall understand where the minus comes from when we come to what we call the minors and cofactors of a given matrix. So the minors and cofactors of a given matrix will help us to understand why this one becomes a positive, this one becomes a minus, this one becomes a positive. So, but what is most important is if you are considering A1, you need the value to multiply with A1, you delete the column and the row where A1 lies. So the remaining values, you take their determinant. So which is the determinant of a 2 by 2 matrix, which we have already covered so far. So that is how we obtain the determinant of a 3 by 3 matrix, but we can understand this one very well when we look at some of the few examples. So let us look at some few examples to understand how best we can deal with the determinant of a 3 by 3 matrix. Looking at some examples, we want to determine the determinant of P, which P is given as this matrix here. So we need to find the determinant of this P using the same technique that we have talked about here. So let us look at that. So when we are given P as this matrix here, we can obtain the determinant of P. So we shall say the determinant of P is same as taking the determinant of 1, 3, 7, 2, 0, 1, 4, 2, 1. So looking at this, we said to get the determinant here, simply take the first value. We are considering this row. We are considering this row here, this one. So take the first element, this is 1, times the determinant of the entries which will remain when I delete this row and this column. So let us delete this row. When I delete this row and this column here, what I remain with is 0, 1, 2, 1. So I will take the determinant of this minus the next value is 3. So I will get 3 times 3 times. Now I will get the determinant of 3 is here. I will now eliminate this and this row where 3 lies. So when I eliminate this and this row where 3, this column where 3 lies, then I will remain with this entry 2. I will remain with 1. I will remain with 4. I will remain with 1. Then again I add there. In this same row we are having 7. We are having 7. So what we do again, we shall have 7 times determinant. Now what we shall do again is to look at where 7 is. 7 is here. But if 7 is there, what we shall do is now we shall eliminate the row and column where 7 is. So this is the row, this is the column, and this one here is the row where 7 is. So when I eliminate this and this one, I will remain with 2, 0, this is 4, and this will be 2. Okay? So from there, what shall we have? We shall have 1 times, you know how to get the determinant here? Get the product, that is 0 times 1 minus 2 times 1. Then again minus 3 times, get the determinant here, 2 times 1, 2 times 1 minus 4 times 1. Again we shall have plus 7 times in, that is the bracket, we shall multiply 2 times 2, 2 times 2 minus 4 times 0. So what shall we have there? We shall have 1 times, this will be 0 minus 2 minus 3 times, this will be 2 minus 4 plus 7 times, this will be 4 minus 0. So what will it give us? It will give us 1 times negative of 2 minus 3 times 2 minus 4 is negative 2 plus 7 times 4. And this will give us negative 2. Negative 3 times negative 2 is positive 6 plus this one here will give us 28. So what will this one give us? This negative 2 plus 6 will give us 4 plus 28. And this will give us 32. So this implies that therefore the determinant of that matrix P is actually 32. So that is how we obtain the determinant of a 3 by 3 matrix. So to take you back on exactly what we have done, we have simply looked at 1. You get that 1, the first value 1. After getting the first value 1, you will multiply it with the determinant. This is 1. So eliminate where 1 lies, the row and column where 1 lies. Then get the determinant of these remaining ones. So that is what you get. Then the next, so that is 0, 1, 2, 1. So that is what we have done here. Then the next procedure again, you will subtract 3. 3 times, where does 3 lie? 3 lies in this column and this row. So when you delete them, what remains? 2, 1, 4, 1. So you will remain with 2, 1, 4, 1. Like that. So again, plus 7 times, where does 7 lie? 7 lies in this column and this row here. But when you delete them, what do you remain with? 2, 0. You remain with 2, 0, then 4, 2. So you know how to get the determinant of a 2 by 2. So get these determinants and multiply by these values, and you try to simplify, and that will be your answer. So let us look at example number 2. We still need to look at the determinant of this matrix B. We need to get the determinant of this matrix B. So let us look at the determinant of B. So we shall do the same. We are interested in getting the determinant of B. So it will be same as getting the determinant of 8, 4, 3, negative 5, 6, negative 2, 7, 9, and negative 8. So we need the determinant of this. But the determinant of this is same as get the first value. We are considering this row here. We are considering the first row. So the value here is 8. So we shall have 8 times the determinant of, so 8 times the determinant of, where does 8 lie? 8 lies in the first row, first column. First row, first column. So delete the first row, first column. What remains? It will be 6, negative 2, 9, and negative 8. Minus, the next value is 4 in that first row. Then you will remain with the determinant of. The determinant of. So where does 4 lie? 4 lies in this first row, but second column. First row, but second column. So if it lies in the first row, second column, delete the elements in this row, in this column, and elements in this row. What do you remain with? You remain with negative 5, this value, then 7, then negative 2, and negative 8. Then again add there. Then in this row again we are having a 3. Then we shall multiply 3 with, we shall now look at where does 3 lie. 3 lies in this one here, this first column, and this first row here, and this last column. So we are having first row, third column deleted. So when we delete this and delete this, what do we remain with? We shall remain with negative 5, 6, 7, and 9. That is what we remain with. So try to simplify this. You know how to deal with a 2 by 2, the determinant of a 2 by 2 matrix. So we shall now have this as 8 times, get 6 times negative 8, subtract 9 times negative 2. Then minus 4 times, get negative 5, multiply by, we are multiplying this and this, negative 8. Again, subtract there, negative 2 times 7. Then we shall add there 3. We shall add there 3 times negative 5 times 7. Negative 5, we are multiplying this and this, that is negative 5 times 9, minus 7 times 6. Then try to simplify. So we shall have 8 into 6 times negative 8. We are getting 6 times negative 8, which will give us negative 48. Then we are subtracting 9 times negative 2, which is negative 18. We have minus 4 into, get negative 5 times negative 8, it will give you positive 40, minus, get negative 2 times 7. Negative 2 times 7 will give us negative 14. We shall add there, this one here is 3. So we are getting 3 times, get negative 5 times 9, which is negative 45. This gives us negative 45. Then get 7 times 6. 7 times 6 will give us minus 42. So we shall simplify this further. We are having 8 times, get negative 48 plus 18. We have negative 48 plus 18. It will give us negative 30. Then minus 4 times, when you look at this, this will be a plus. So 40 plus 14, it will be 54. Again, add there 3 times, this is negative 45 minus 42. It will give us minus 87. So let us try to simplify this one. 8 times negative 30. 8 times negative 30 will give us negative 240. Minus, get 4 times 54. It will give us 216. Then get 3 times 87. 3 times 87, this is a negative, so we shall have minus of 261. So this will give us 717. So when you get negative 240 minus 216 minus 261, should be able to get a negative 717. So this will be the determinant of B. So therefore, the determinant of B is same as negative 717. So you should be able to do the remaining ones with ease. So the most important part is that you will be considering the first row, then consider each of these entries in that first row. Then whenever you are considering a number like 8, delete the row and the column where 8 lies and get the determinant of the remaining entries. The same applies to 4, but remember we consider a plus, minus, and a plus. So it means the 4 will be carrying a negative. So it will be negative 4 times, delete the row where 4 is and the column where 4 is. Then take the determinant of the remaining entries. So you should be able to deal with that. So you will try part C, that is the determinant of this matrix A. Then we can now again solve together for the value of A when we are given that the determinant of this matrix is equal to 0. We are interested in finding the value of A when we are given that the determinant of this matrix here is equal to 0. So let us see how best we can get the value of A. But the most important thing is to know how to get the determinant of this matrix. So given that the determinant of this is equal to 0, we need now to look at the determinant. We shall consider our row here. When you consider that row, when we consider the first row, this one here, then we shall begin with the first value, which is a 2. We multiply together with the determinant. What do we get, or what are the remaining entries when we eliminate the first column, first row? Where 2 is, 2 lies within this. So when we eliminate this and this, then we take the determinant of the remaining ones. So that is 2A, 0A. Then minus, remember this value here is given minus 3 times the determinant of the remaining entries. When you eliminate where 3 lies within this column, within this row. So we shall eliminate this row and this column here. So we remain with a 3, we remain with A, we remain with -1 and A. Again, we shall add there. The next value is a 4 times. Then eliminate the row where 4 is and the column where 4 is. So we eliminate this and this. What remains here is a 3, a 2, -1, and 0. And this, they are telling us that this determinant is 0. So we shall have 2 times, now try to get the determinant of this matrix. 2 times A, 2 times A, minus 0 times A, minus 3 times, so we get this times this, that is 3 times A, minus -1 times A. Then plus 4 times 3 times 0 minus -1 times 2. The whole of this must give us a 0. So we are having 2 times this one here will give us 2A minus 0 minus 3 times this one here will give us 3A minus this one here is minus of A plus 4 times 3 times 0 is 0 minus this is -2 is equal to 0. So from here we shall have 2 times 2A minus 3, this one and this will give us 4A plus 4. Let us look at this. This one here is positive 2 times 2, which is equal to 0. So this one here will give us 4A minus 12A, which we are adding there. We are adding there 8, which is equal to 0. So this one here will give us -8A plus 8, which is equal to 0. And basically we shall have this as -8A, which is equal to -8 divided by -8 by -8, and This will imply that our A will be positive 1. So we are able to get the value of A. The value of A is 1. So if you are given any matrix, which is a 3 by 3 matrix, I hope you are now able to get what we call the determinant of that given matrix. Let us now talk about the minors and cofactors of the matrix. So we shall say, if we consider the matrix A, which is given by AI of J, then the minor of an entry Aij of a matrix is obtained by taking the determinant of the matrix that will be obtained by deleting the ith row and jth column of that given matrix. And we shall be denoting the minor of an entry Aij as M of Ij. What do we mean here? If you are talking about the minor of an entry, you look at which column is it lying in and which row is it lying in. So here I represents the row and J represents the column in which it is lying in. So we shall obtain the minor of that given entry by simply taking the determinant that we shall obtain after we have deleted the ith row and the jth column in which that entry is lying in. It is actually related to how we have been obtaining the determinant of a 3 by 3, whereby we would eliminate the row and the column where an entry was lying. So the same will apply to this. However, this will be done for all the entries within the matrix. So in the previous case, we were simply considering a matrix, and we simply consider the first row and we delete the first row and first column to get the determinant that corresponds to A1. So, but for this case, we shall now be doing this one here for every entry, that is for entries in the first row, the second row, the third row. So all the entries will be affected. So let us look at the cofactor now. To get the cofactor of an entry Aij, we shall be taking or getting the cofactor of that given entry by using this formula that it is -1 to the power of I plus j. So I represents the row and this one represents the column. So we shall multiply by the corresponding minor. Remember that we first of all get the minor, then after getting the minor, we can get what we call the cofactor. But let us look at an example to understand better what we are talking about in this definition. So we shall consider the matrix A, which matrix is given by this. We shall need to get the cofactors of each of these entries 0, 2, 1, 3, -1, 2, 4, 0, and 1. But to get the cofactor, then we shall first of all need to get what we call the minors. So let us look at how best we can get the minor. For example, to get the minor of this entry 0, where does 0 lie? So let us try to relate this matrix here with the general 3 by 3 matrix. So we know that this 0 lies in the first row, first column. So if we are interested in getting the minor of the element in the first row, first column, then what we shall do is we shall look at where 0 is. We are interested in the minor of this value. So we shall delete the first row, this one here, and the first column. Delete the first row, first column. When you delete the first row, first column, get the determinant of the remaining entries. That will be -1, 2, 0, and 1. -1, 2, 0, and 1. You know how to get the determinant of a 2 by 2. Get negative 1 times 1, negative 1 minus 0, and this will give you negative 1. Having got the minor, then get the corresponding cofactor of this entry in position, that is first row, first column. And that one is given by the formula that negative 1 to the power I plus j. I is 1, j is 1. So it is 1 plus 1 times m1, 1. So this will be same as negative 1 to the power of 2 times m11. m11 is negative 1. This will be 1 times negative 1, and this will remain as negative 1. So this will be what we call the M11. So M11, that is the minor of an element in the first row, first column. And you obtain it by deleting the first row, first column. By deleting this first row, first column. So what we shall get will be the minor 1, 1. Let us go on and see how to get the next now. So now to get the minor 1, 2. Now we are talking about 1, 2, but what is in that position? We want the minor of this. To get the minor of 1, 2, you will delete the first row, second column. You will delete this. Get the determinant of the remaining entries. We remain with 3, we remain with 4, we remain with 2, we remain with 1. So when you look at this, you can easily get the determinant of this, which is 3 times 1 minus 2 times 4. This will give us 3 minus 8, which is negative 5. So that is the minor 1, 2. So get the corresponding cofactor. Cofactor 1, 2. We said cofactor is given by the formula negative 1 to power I plus j, which is, this is representing I, this is representing j. So that is 1 plus 2. Then times the minor of ij, 1, 2. So what will this give? Negative 1 to the power of 3 times m1, 2. But you have already got m1, 2 as negative 5. So this will give us negative 1 to power 3 is negative 1 times negative 5, which will give us positive 5. So this will be the cofactor of 1, 2. This will be the minor of 1, 2. So remember, we shall do this for all the entries here. So the next entry is this one here. So to get the minor, this one is in position of 1, 3. To get the minor of 1, 3, delete the first row, third column. First row, third column. Get the determinant of the remaining 3, 4, negative 1, 0. When you do that, get the determinant as usual. 3 times 0 minus 4 times negative 1. What do you get? This is 0 minus 4. And this will give us a 4. Then again, get the cofactor of 1, 3. Cofactor is given by negative 1 to the power of 1 plus 3. 1 plus 3. Then times the minor of 1, 3. What will that one be? Negative 1 to power 4 times 4. But this is 1 times 4, which will give us 4. So this will be the minor of 1, 3. So the same applies to the next element as well. So the next element will be this 3 here. So we are doing the minor, we are getting the minor for 0, 2, 1, 3, negative 1, 2, 4, 0, 1. So we are getting the minors of each of these entries and the corresponding cofactor. So to get now the minor of 2, 1. 2, 1, we are talking about this element. We shall again look at 2, 1. Delete this row, this column. So delete second row, first column. Then get the determinant of the remaining ones. 2, 1, 0, 1. What will you have? 2 times 1 minus 0 times 1. This will give us 2. So what is the cofactor to 1? Cofactor to 1 is negative 1 to the power of 2 plus 1 times the minor to 1. This will give us negative 1 to the power of 3 times 2. This will give us negative 1 times 2, which is same as negative 2. So this will be the cofactor of 2, 1. So if that is done, let us now again look at the minor of the next entry. So the next entry is this one. So we need the minor of this one is in position 2, 2. So minor of 2, 2. The minor of 2, 2, we shall see which minor 2, 2, we shall eliminate the second row, 2, 2, second column. What do we remain with? We shall remain with 0, 1, 4, 1. Then get the determinant there. 0 times 1 minus 4 times 1. This will be same as 0 minus 4, and this will give us negative 4. So this is the minor of 2, 2. But after getting the minor, get the cofactor 2, 2. Cofactor 2, 2 will be negative 1 to the power of I plus j, 2 plus 2, times the minor of 2, 2. So we shall have negative 1 to the power of 4 times negative 4. This will give us negative 4. Negative 1 to the power 4 remains positive 1 times negative 4, which will be negative 4. So we shall do this the same for all the entries. We shall do the same for all the entries. So what will be the next entry? The next entry is this. So we need the minor of 2, 3. The minor of 2, 3. The minor of 2, 3 will be obtained by deleting the second row, third column. Second row, third column. So when we do that, get the determinant of the remaining ones. 0, 2, 4, 0. So when you do that, you will get 0 times 0, 0 times 0 minus 4 times 2. And this will give us 0 minus 8, which is same as negative 8. So from there, get the cofactor 2, 3, which is negative 1 to the power of 2 plus 3 times the minor of 2, 3. And what will that one give us? Negative 1 to the power 5 times negative 8. This will give us negative 1 times negative 8, which will give us positive 8. So this will be the cofactor 2, 3. So after doing that, get again the cofactor of other entries as well. So the next will be to get the minor of this one now. So the minor of 3, 1. The minor of 3, 1 will be same as deleting the third row, first column. When you delete that, you remain with 2, 1, negative 1, 2. When you get the determinant, it is 2 times 2 minus negative 1 times 1. This will give us 4 minus negative 1, which will give us a 5. So get again the cofactor 3, 1, which is negative 1 to the power of this plus this. 3 plus 1 times the minor of 3, 1. And this will give us negative 1 to the power 5 times m3, 1, which is 5. So this will give us negative 1 times 5, which is negative 5. So we have got that. The next one will be the next one will be to get the minor of 3, 2. We are getting now the minor of this. Minor of 3, 2 will be same as eliminating the third row, second column. When you do that, you are remaining with 0, you are remaining with 1, you are remaining with 3, you are remaining with 2. Get the determinant, 0 times 2 minus 3 times 1. So this will be 0 minus 3 times 1, which is 3. This will give us negative of 3. Get the cofactor 3, 2, which is negative 1 to the power of 3 plus 2 times the minor of 3, 2. This will give us negative 1 to power 5 times negative 3. This will be negative 1 times negative 3, and this will give us positive 3. So this will be the cofactor of that entry, and this will be the minor of that same entry. And lastly, we shall talk about the minor. We shall talk about the minor of 3, 3. We are talking now about this. The minor of 3, 3, we are removing or deleting the third row, third column. When you do that, you will get the determinant of the remaining ones, 0, 3, 2, and negative 1. When you do that, you will get 0 times negative 1 minus 3 times 2. And what will it give? 0 minus 6, which is equal to negative 6. Now get what we call the cofactor 3, 3. The cofactor of 3, 3 will be negative 1 to power 3 plus 3 times the minor 3, 3, which is negative 6. So this will be negative 1 to power 6 times negative 6. And of course, this will be 1 times negative 6, which will be negative 6. So this will be the cofactor of 3, 3. This will be the minor of 3, 3. So after getting the minors and the cofactors, you have got the minor of this, the minor of this, the minor of that, the minor of this one, this one, this one, this one, this one, and that. So make a matrix of minors. So if you are required to get the minor matrix, then place them where there is a 0, place the minor corresponding to 0, place the minor corresponding to this entry, place the minor like that, and form the matrix of minors. And likewise, we have already got the cofactors corresponding to each of these entries, so get the cofactor matrix. So from there, we shall be able to get what we call the minors and the cofactor matrix of any given matrix. So, looking at this one here, you can easily see that we have obtained all the minors and all the cofactors. So, these are the minors we have obtained, these are the minors we have obtained, and we can easily form the matrix of the minors. So that is this one here is M11, this is M12, this is M13. So place them like that. So this is the minor 21, this is the minor 22, this is the minor 23, minor 31, minor 32, minor 33. So you can easily get the matrix of minors. So likewise, we have got what we call the cofactors of each of the minors. So still, you can come up with the cofactor matrix. Now let us look at the cofactor matrix. So, combining all the cofactors you have obtained, form a matrix, form a single matrix of the cofactors. So, from that, we can easily form this matrix here. From the cofactors that we have obtained, we can easily form this matrix. So I'm very sure you are now able to get what we call the minors and the cofactor matrices. So when you are given a matrix and you are required to get the minor matrix and the cofactor matrix, those are the some of the samples techniques that we use to obtain the minors and the cofactors. So you will try out some few questions. I will give you some few questions to try out, and you obtain the minors and the cofactor matrices.